For the sake of completeness, we now write down the stream function for when the flow is compressible, that is, when the density of the fluid is changing. Although it is not so much required in real practice, but still it has a value because there are flows when at times the density is changing and the flow is compressible. So the continuity equation in two-dimensional in a steady motion will then be written by this, that instead of writing divergence of V equal to 0, we write divergence of rho V equal to 0. And in component form, it is written in this form. And you remember, just in the like manner as we defined psi for del u by del x by dx plus dv by dy equal to 0. Here, when rho is being multiplied with the components u and v, then we define the sign function for compressible flows in a similar manner, in a very like manner, and therefore it will be, if the stream function for compressible flows are psi of rho, this is meant to be rho. Rho means that compressible flow, that is, the density is changing. It's just to indicate that the density is changing. So rho of u will be equal to d psi partial derivative of psi divided by dy, and rho v will be minus of. So it's almost the same thing, except a little difference in the notation that we are using here. Instead of psi, we write psi rho, only to indicate that rho is changing. And on the left hand side, instead of u, we write rho u, and instead of v, we write rho times v, and we define psi to be the same function, the stream function. This satisfies the continuity equation, and that is the main requirement. Although it's not too much popular as the stream function psi in the incompressible flows, but still it is required to be used when we are considering the compressible flow field. And many times that is required in commercial computer fluid dynamics algorithms, where they have to make use of that, because many of the products, many of the industrial activity that requires to consider a real fluid which has the property of the compressibility. So for that sake, that is where we will need to keep this possibility that psi may change with changes in the density.